Okay, thank you everyone for joining me. This is a new podcast that we're launching called the Cloud Native Compass, which focuses on containers, Kubernetes, WebAssembly, and everything in between. And today's episode, we are talking about WebAssembly and server-side WebAssembly. I have three wonderful guests who will each introduce themselves now, and we'll start with you, Kevin.
So I'm Kevin Hoffman, CTO of Cosmonic. Created the WasmCloud open source project, wrote a book called Programming WebAssembly with Rust, and just in general have been using and experimenting with WebAssembly since before the standards were fully baked.
Thank you very much. Connor.
Hello, I'm Connor Hicks. I'm the founder CEO of Suborbital. We focus on using server-side WebAssembly for the purposes of building extensibility into SaaS applications. So we build effectively a plugin system for SaaS cloud-based apps. And I was experimenting with WebAssembly for probably 2 or 3 years before that. So I've seen a little bit, but don't think I've been around quite as long as Kevin.
Hi, everyone. My name is Kate Goldenring. I'm a senior software engineer at Fermyon, where we're excited about serverless WebAssembly applications. And previously, I came from a Kubernetes background. So I'm still co-chair of the IoT Edge working group and the CNCF. So still enjoy the Kubernetes space and currently have moved into this new WebAssembly world, excited about the serverless side of it.
All right. Thank you. So as part of your introduction, you've all obviously shared a little bit about how you got into WebAssembly, but I'm hoping we can dive into that a little bit more and just kind of understand not just why you're here, but like what your path was to get to WebAssembly. What did you find interesting? What piqued your, like what really got you on that road to join in us in the WebAssembly landscape? So there's no right order here. If anyone wants to tackle that question first, please feel free to blink twice, put up your hand, anything you wish.
So a while ago, and this was, when we were all riding to the office on the backs of dinosaurs, I was trying to solve a enterprise problem where I had a number of teams that were all trying to contribute business logic to a shared portal. And so one of the problems I was trying to fix was, how do I make it so that these teams can all work in the environments that they're comfortable in and the languages that they're comfortable with, and still be able to contribute to this shared target platform. And so one of the many thousands of rabbit holes I went down took me to Asm.js, and then I also did some experimenting with this thing called CloudABI, which to me feels like a sort of a spiritual ancestor to WASI. And from there, the rabbit hole just grew bigger and bigger until I found my way to WebAssembly and wrote my first Hello World in C, and then once I figured out how to do it in Rust, it was pretty much all downhill from there. And the technology that ended up helping these various teams do what they needed to do is what ultimately ended up as part of the open source WasmCloud project.
I'll go. For me, it was a COVID, playing on my own open source projects type thing where I got frustrated with how containers were behaving in a particular project that I'd been playing with on the weekends while we were in lockdown. And I had kind of fiddled around with WebAssembly before that, but I decided to try to pull it into this project I was working on to try to get faster startup times for basically a job processing framework that I was building. And I pulled it in. It was a very rudimentary Rust implementation with a couple of very basic bindings to be able to, just read system stuff. This was when WASI was still a little bit, in its early days. And the thing that really got me hooked was that performance that I was able to pull out of the job scheduling system that I was building compared to the previous implementation of it that was based on containers. And so, that one weekend of hacking was enough to convince me that there is some real utility for WebAssembly. And then that was about 3 years ago. So now I've been working on it full time since then.
Yeah, I mentioned in my intro that I kind of came from the Kubernetes ecosystem. That's exactly what brought me into the WebAssembly space, which is a bit unusual, but I was maintaining and still am a project called Ocri, which is a CNCF sandbox project. And while I was at Microsoft and we were wondering what would it look like to port this application to being a WebAssembly application. And we had a sister team, which is the Deus Labs team, of which many of those people now came and founded Fermyon, that was working on a project called Krustlet, which was basically a first attempt at what does it look like to run WebAssembly instead of containers on Kubernetes. And so I jumped into that effort and implemented the device plugin manager in that Kubernetes kubelet written in Rust, which is why it's called Krustlet, and kind of saw some of the issues we were having around using a new kubelet implementation as the way of running WebAssembly on Kubernetes, and how just the load of what we needed to do kept getting bigger and bigger because it was a full kubelet. And at that point, many people had switched to moving on to Fermyon, and I kind of got hooked on WebAssembly, seeing all the benefits on the server side that originally were those benefits that were made for the browser. So that made me also join on with Fermyon and keep going in the WebAssembly space.
Thank you. So, all three of you mentioned server-side WASI. For people that aren't that familiar with what the WASI as a specification, right? What that is, maybe we can give them a bit more context and why that's important for today's discussion.
So I guess I'll start with the hard part, which is that WASI is in flux, and it's one of those things that means something different to different people, even though it's an official standard, right? So when you look at WASI, some people, and again, the documentation in different places treats it this way, is they feel like they treat WASI as though it's like a POSIX replacement, but for WebAssembly. And it may have originated that way and with that goal in mind, but the way things are going today, it seems more like the WASI is more along the lines of the implementation technology that's enabling things like the component model. And so I guess the short version is that WASI was originally created as a way to give WebAssembly modules access to external services, but those external services were low level, like being able to read from a file descriptor or being able to write to standard out, things like that. And that seems to be evolving towards the component model, where now the idea is that the external services are high-level abstractions like web client, web server, key value store, things like that.
Oh, I was just going to add, just because I don't know if we've said it yet, WASI stands for the WebAssembly Systems Interface. So it's what Kevin's mentioning. It's those interfaces that are allowing a guest or a WebAssembly module or soon to be component to talk to a host and use those resources from the host. And it's essentially just a WIT or that type of file where you're defining all these functions that give access to your guest code, those resources on the host. And as Kevin mentioned, it's been evolving from providing just the bare minimum of what you may need to run an application directly on the server into more of this idea of what does a cloud look like that is made up of WebAssembly functions. And so we're getting those key value services and other kinds of services that you would expect from the cloud. And all that's being defined by these WIT interfaces that give access to host resources or other resources that the host can point out control to.
Yeah, another way I like to look at it is think of an interface in a programming language, being able to define an abstract set of methods or behaviors for an object, and then having multiple implementations of that within that language. You can think of WASI and the associated component model as a generalized version of that, where you can define a set of interfaces. Some of them will be common and set by a standards body as, the things that you need every day, like accessing randomness and clocks and stuff like that. but some of them will be user generated. And at the end of the day, you result in a shape, an external set of inputs and outputs that any module written in theoretically any language could conform to. And if you load a module that conforms to that interface, it will theoretically satisfy the requirements of your program. And that's, I think, where we want to get to. And it's just a matter of working through that very complicated problem in the standards body. And that's what's happening right now.
Okay. So what I'm going to try and do is repeat all of that back in a summary fashion and hopefully not get too much of it wrong. But feel free just to let me know. I'll make some assumptions as I go. But, I think what I heard from Kevin is if we can think of WASI as something like POSIX, but not directly like POSIX, then it allows us to be able to speak to the host file system, to the networking stack, and so forth. It feels like it was said that the component model is an evolution of this or an implementation of this. I'm not sure which, but maybe someone can clarify that. But what that means is both. yeah, we'll go with both. Or it depends. I like the answer too. Depends what way you squint your eyes. But, we have the component model now. And the reason that we need this, right, even if we go back a little bit more, is that WebAssembly as a runtime is a really strict sandbox, right? Is it safe to assume that it has no concept of a file system, right? Because it runs in a browser. It has no concept of, I don't know. I mean, it has networking, right? But does it understand layer 7? Is it just L4? Does it have none of that? I'm not even entirely sure myself. But these sorts of primitives that don't exist in the sandbox. And the component model enriches that with some of these common interfaces, like Kate and Connor were saying. I think, Kate, your example was KV storage. If we provide an interface to KV get and KV set,
it depends, yeah.
Does that mean the component model can drop in a Redis component, a MySQL component, a simple file component that does file system based KV, and then as a consumer within your WebAssembly program, you don't care? Is that right?
Yeah, I think so there were two things that I wanted to point out. So one is, again, depending on what you're using it as your definition of WebAssembly. WebAssembly on its own, so the standard, the 1.0 freestanding WebAssembly has no concept of networking. So there's no networking, there's no file system access, there's no I/O at all. There's just the ability to take in numbers and give back numbers. And that's essentially a direct result of the sandbox that you're working in. The only thing that WebAssembly on its own, without the assistance of a host, can do is just pure functional compute and access a shared sandbox piece of memory. And that's all it can do. So the first thing that people run into when they do that is they need access to more than just pure compute. And so how do you do that? The first thing that enabled people to do that was WASI, and they were able to then access sandboxed file systems. And what we're talking about as the evolution of that is what you were saying, where the next step is to grant abilities or to grant these interfaces to the guest modules, to the components. So moving forward from WASI's low-level capabilities to the next level up. So, high-level cloud services.
And just to follow up on your question, David, I think you mentioned there that, you can have your guest then point to use different hosts over this interface. So in the key value scenario, you were saying you can do a series of gets and sets. The interesting part about this is, one, like you said, that as a developer, I don't need to care about what the host implementation is or whether I use Redis or DynamoDB, for example. But another part of it is that I could change my mind. So I can have the same WebAssembly module and keep that constant. And then maybe later I want to switch to Redis. Then I don't need to rewrite that application. I just need to change the host side of it. And then one other point I wanted to make is I think WASI and the component model, I personally see them as very related because the specification is moving towards the component model, but I think it's easy to think of them as separate in the sense of I think of the component model as a new way of envisioning applications and the way that we see applications and making them composable and making essentially dependencies. You can click them in place and swap them out more easily. But I think of WASI as this evolution that enabled us to run WebAssembly outside of the browser. That has now decided that a really good way we want to do this, even more so, is with this new way of making applications with the component model.
Yeah, I think what's important that Kate was mentioning, that I think it's subtle and a lot of people don't really see the impact that it's going to have right away, but the idea that you can change your mind at runtime between implementations of these contracts is way more enabling than some of the technologies that have come before it. So in addition to me being able to change my mind about which implementation of a key value store I'm dealing with, I can change that at runtime. I mean, depending on the host, obviously, but I can change that without having to rebuild my code. My code is now no longer tightly coupled to the shape and scale of my deployment.
Yeah, and a kind of adjacent benefit that you would get that I don't think we've really seen with any other technologies is the ability to not only change out implementations at runtime, which will be extremely awesome in its own right, but then also the ability to move code to different layers of the excuse me, the network stack, I guess, if one way to look at it. Like, you can move code from executing in a central AWS region out to like an edge worker style region and not have to change it at all, because maybe in your central cloud you use DynamoDB for KV, but then on the edge you use the Cloudflare workers cache or something like that. And you would be able to either manually or maybe even one day automatically, depending on load or whatever, you could move the execution of that code around and it could just figure out how to make your business logic work with the dependencies that it needs.
Okay, thank you for that. So there's a few different interesting things here, right? Is that we've mentioned containers a couple of times now, and like this containers would be like what we consider almost the standard developer experience for a lot of what we're talking about right now, is the ability to use different backing services, right? But how is WebAssembly changing that? Now we've got a component model and it's this runtime thing that we can swap out and the code doesn't change and all that. That's all very nice. But like, how does WebAssembly really continue to improve that developer experience for developers? Like, why are we seeing what started off as this browser-based technology for doing computation now being used for functions and service within game engines, even on mobile phones? And, you know, desktop extensibility is another one. Like, VS Code is probably going to have a plugin system that's mostly WebAssembly based at some point. So why are so many people being drawn to this versus the status quo of like containers?
Yeah, I think there's 2 or 3 main points depending on who you are and what you care about. One of them is the fact that WebAssembly modules are often far more lightweight than your average container. That's not always 100% true, but on the average case, that is true. And so therefore, storing them, downloading them, starting the execution of them is often much faster. The second is the security posture. A lot of people see, since WebAssembly was an evolution of something that came out of a web browser, and web browsers run untrusted code all day long safely on your laptop, since WebAssembly was born from that, it could bring some real security improvements to cloud execution as well, both in terms of like third-party dependency vulnerabilities and just malicious stuff that makes it into your sort of source code, but also intentionally running untrusted code. And then the third is just a common target for multiple programming languages. Containers somewhat satisfy that, but the ability to, as we just talked about in the last few minutes, like have a common set of interfaces, capabilities, APIs available to you, and then being able to have all the different programming languages that you care about target that exact same environment and not have the overhead of a Linux-like environment to go along with it has a couple of really great benefits.
Yeah, there's a couple of things that I think people take for granted. So one is that the idea that containers are portable is untrue, right? Containers aren't actually portable. There's a whole cottage industry of tools to help compensate for the lack of portability around containers. And there's a saying, I'm not sure where the quote came from, but you own what you deploy. So your unit of deployment is everything that you own. And so the larger the thing that you deploy, the larger your ownership burden is. Right? So we started off deploying in virtual machines an entire operating system plus the application that we needed to deploy. And so we own basically everything from top to bottom. Then with containers, we own a slice of an operating system and our application and all the application dependencies. But with WebAssembly, all we own, theoretically, is our business logic. We don't own the external dependencies anymore because we're no longer shipping them with our WebAssembly modules. Right? Assuming that the future with this component model turns out the way we all want it to, I don't own the implementation of the key value store for my WebAssembly component that I'm shipping. I can ship that somewhere, and then the environment is the thing that owns that database. So I may still care about it, and because I may, have multiple hats, I may still be the one who's, dealing with the implementation and the installation and configuration of all that stuff. But in terms of the developer working on just that module, they don't have to worry about owning that full stack anymore. All they own is their use of the abstraction.
Okay. So thank you for saying that containers are not portable. As a developer working on an M1 Mac, I guarantee you containers are not build once, run everywhere. I think the tooling there is really painful right now. And it's one of the draws for me personally with WebAssembly is that you do just, you build it once, you get the WebAssembly binary artifact, whatever that is, and it does run everywhere, which is really cool. But I'm going to take that question that I asked, I'm going to flip it around a little bit and say, if people are listening and they like the idea of WebAssembly, they like the idea of working in random languages. We've already said Rust 3 times now, so let's get that up to at least 12 before the end of the episode. But they want to explore with languages. They want to compile to us a common, ubiquitous target that does run anywhere. What kind of applications does the current state of the component model in WASI really excel with? And I'm assuming rewriting Postgres is not the answer there. So what can we do today?
Yeah, I think you pointed out of saying a long-running daemon-style application like a database is not what you probably want to target for WASI WebAssembly at the moment. What seems to be a really good use case for WebAssembly right now is serverless. If you think about the previous unit for serverless, or maybe micro VMs is a common one for AWS Lambda, Firecracker micro VMs. Those take about 125 milliseconds for cold starts, while WebAssembly is sub-millisecond. And so you can really see event-driven applications that need to run from a cold start, execute, and go down in millisecond or sub-millisecond time. WebAssembly is a really good use case for that.
Yeah, I want to. I don't remember who brought it up, but the ability to change your mind also extends to this type of thing. So Kate's point is excellent in that WebAssembly is great at serverless, but I think what's even more important is that you're not locked into serverless with WebAssembly. So you can run a WebAssembly component as a stateless wake on demand function, or you could leave it running and have it, have 500 instances of your WebAssembly module distributed across, hundreds of different servers. And your decision at that point is just a choice of which runtime or which host you want to deploy your component into, and your your choice of using serverless or a microservice or some other hybrid is no longer a design once and live with the consequences forever decision. You can actually change your mind. You can go from running it serverless in a test environment on your laptop to running it distributed across multiple clouds in production without having to rebuild your modules.
Okay, I'm going to ask the hard question now, and it's like, the what's missing, like I don't even know how to phrase it in a way that's going to even help you answer it. But let's assume we have a world 10 years from now where all applications are written as WebAssembly. What are we doing to push into these things where we quite miss the mark right now? Like, how do we write long-running daemon processes with WebAssembly? How do we have databases that are purely written in WebAssembly? Is it just a maturity thing? Is it a tooling thing? Is it the component model? We need a V2. Like, what's the trajectory there? What's the path forward to being fully WASM?
I think we need a V1 before we need a V2. Yeah, there's a couple of things that come to mind. One is, debugging and observability. This is something where we've seen a bunch of prototypes. We've seen a bunch of projects working towards being able to easily debug and observe WebAssembly execution. But just like the component model, they're in flux. People are still trying to agree upon the best way to do it, and the tools aren't fully baked yet. The component model itself, like I said, we're not even at V1 yet. So getting to something that we all agree on, and we can say, okay, this is going to be stable for the foreseeable future, and future updates will require breaking or migration or whatever. Like, that is going to be an important inflection point for the whole industry. And then I think just having the different language tool chains catch up to that. Once we have that V1 of the component model, we then have more work to do, right? Having just the spec isn't enough. Rust will obviously get there quickly, but then all the other languages need to integrate the component model tooling, be compliant with the spec. And there's an additional layer of complexity for the interpreted languages like JavaScript and Python for all of those things, the component model and debugging and the tooling. So there's just a couple of steps I think we need. All of those things, we're seeing progress on them. And if we kind of get to this point of coalescing on the standards and the tooling and the tool chains, then we should be able to see that future pretty clearly.
I think at a really high level, so Connor mentioned a bunch of different types of tooling, but in general, the tooling is just not there yet. There are some languages with better tooling than others. So I think we would all agree that Rust probably has the best tooling ecosystem right now. But so the tooling obviously needs to evolve, but I think even at a higher level is that WebAssembly is not yet a boring technology. So part of the giant hype cycle around WebAssembly is that everybody is trying to get into the space, and the difference between now and the ideal future is WebAssembly becomes boring. It no longer is an end goal and is just a checkbox that you tick when building something. You write your code, it comes out as a component. All the tooling knows how to deal with components. You have tooling that stitch components together, and it's all just part of the day-to-day routine. When WebAssembly is as easy to produce as an ELF binary, then that's when that's part of the tipping point when things go from the dangerous part of the adoption curve to everybody's using it, even if they don't know about it.
Yeah, I think Kevin's exactly correct in that if we get to a point where WebAssembly fades into the background in the same way that a lot of developers don't even know that they are interacting with POSIX or whatever, like, so it should proceed to a similar level of so boring and so reliable that it just is a standard, then we will have succeeded.
And just to add on to the comment about it being a standard, it is a standard and it's community driven. So there is a pace at which things move. And that does require that we get certain interfaces in place. Recently, we got threads, we got socket accept, but without those things, you can't even imagine a long living daemon application. So you can see we're moving forward, but there are other proposals that still need to happen. And the other thing that we need is a registry for all of these different components. So if you WARG is what it's called, but if you can imagine one place where you can centralized use other people's components and make a composable application. So a developer experience that's easier around that too. So I don't need to know how to make every component or even understand the low level WebAssembly tooling.
Yeah, I think the day will come when we'll have a nearly universal package registry, like Kate's point about Warg and having this library of components you could pull from. Like that is one of the big dreams I think of WebAssembly, is that I could be writing a Python program. I need a library to do some hashing algorithm that I don't know how to implement in Python. I could pull down a package that implements that algorithm, and I might not even have any idea what programming language that algorithm was written in. It could be C, it could be Rust, and I won't know or care what language that came from, because the tooling will just understand that, hey, this is a component. I can understand how to load and run a component or compile it into my larger program or whatever, and we just continue on.
Yeah, I think that's a subtle and often overlooked point, is that when we switch to the component model, the size of the Lego bricks that we're using to compose our applications is much smaller. And so when we talk about how it's WebAssembly is language agnostic, or you can use any language, a lot of people immediately think, well, that just means I can choose one language to build my application in, and another team can choose another language. And while that's true, I think some of the real underrated power comes from what Connor was mentioning, which is if I am trying to build an application, and let's say I need to do some heavy duty cryptography type stuff, and there's a different language where that's easy to do in its WebAssembly targeting form. And so I could write my business logic in Go, build a WebAssembly component out of that, and utilize another component that does the quote unquote hard stuff for me. And the component that I link with at compile time or runtime, that could do that stuff for me, and I don't care what language it's written in. All I care is that it satisfies the contract. So that the idea that I have these contracts and interfaces that are being satisfied at a high level, that means that I can interchange things like my database or my web server and things like that. But at a low level, it means that I can actually build applications out of units of compute that are smaller than what we think of today as traditional libraries. And that's super powerful, I think.
Yeah, I think that's one of the often understated powers of WebAssembly. And I hadn't really thought about it directly like this. And, there is no WebAssembly package thing yet. But using NPM as an example, if I'm working on an application and I just do NPM install 3 different packages that are written in 3 different languages, but all get built to WebAssembly, and I'm able to consume them in a really strong developer experience fashion, that's really powerful to a lot of people, especially if you have a data science team that want to work in Python, you've got your web dev team that want to work in Ruby, you've got, your infrastructure team who are all Go and Rust, and then it doesn't matter at this point in time anymore. We're just consuming each other's interfaces, abstractions, and components, which very, very, I like that future. That's the future I'm here for. I want that one. So. All right. Well, I know 2 of you, Kevin and Kate, you were both at KubeCon. I'm not sure if you were there, Connor, right? No. Okay. But I'm assuming that's not the only conference on the circuit. You've all been to many conferences over the last 12 or 24 months or whatever. Like, I'm curious, just when you speak to people and you say WebAssembly, is there an instant acknowledgement? Are we at a phase where people are like, oh yeah, WebAssembly? Or is it like oh, what's that? Tell me more. Like, what's that like these days?
I think the way that I have seen that evolve is just standing in front of our Fermyon booth at KubeCons. And just a year ago at KubeCon North America, so I guess less than a year ago, the first initial question of, hey, do you want to learn about WebAssembly? There was immediate, what? And now it's evolving to people already know what that is a lot of times. And that's been really interesting to see in just 8 months or so, how the just that experience of people walking by, they already know that. And oftentimes they want to hear more and learn more. And we had several WebAssembly workshops at KubeCon. We had one about spin on AKS, and then Wasm Edge had another one. And there were like 350 people at our session for this workshop, hands-on with WebAssembly. And then seemed to be around like 200 or so at the Wasm Edge one. So people not only are hearing about it and interested in it, but also wanting to get hands-on with it. And it seemed like that's happened fairly quickly.
Yeah, the session that I gave at KubeCon, like you said, I've presented at a couple of conferences and have been for a while now. And I can distinctly remember, giving presentations when there were like 3 people in the room total, and those 3 people didn't know what WebAssembly was. And then there was a next step where there were more interested people in the room, but none of them had really experimented with WebAssembly yet. And at this most recent KubeCon, the room was completely full, which is a totally new experience for WebAssembly, for the WebAssembly community. And in addition to there being people that were just interested in the technology, there were actually people who raised their hand for people who'd used WebAssembly in anger and had been building real things and deploying real things with it, not using a browser, which, I'm actively trying to make that the future, and that completely surprised me. I just had no idea that it was catching on that quickly. And from the WasmCloud booth and Cosmonic booth and just sort of walking around and talking to people generally seem to know not only what WebAssembly is, but it's no longer a really, really hard sell trying to tell people that WebAssembly has a place outside the browser. I think we're starting to get to the point where the early adopters and the innovation curve now includes people that don't just assume that WebAssembly is a browser-only technology, and I think that's a huge milestone for the community.
Yeah, I think it speaks a lot that a first edition of a new WebAssembly conference, WasmIO, that happened a couple of weeks ago, was able to draw such a great crowd. And this was something that was not attached to a larger conference like the Wasm Days at KubeCon. Those ones have been steadily getting bigger. Like Kevin said, we've had full rooms and whatnot. But even a brand new conference was able to pull in enough people to be extremely successful. And also, the quality of speakers is I think, a given, because everybody in this community is very friendly and talented. But yeah, it's been a steady increase, and I think the rate of change is increasing as well as people see things getting a bit more mature. They see examples of real world usage, and they start to realize where the use cases are, filtering out to. It's definitely becoming easier to talk about, easier to convince people of its utility, and you're finding a larger percentage of people just inherently already knowing it, which is great.
And on the note of WasmIO and great speakers, I just wanted to shout out PJ Laskowitz talk on basically all these different production scenarios. He's with the Omnify Foundation, and I was so excited by the end of his talk. He was mentioning how it's being used in production in medical devices, automotive, the edge. It was just stuff that I had no clue was already happening in production. So if you want to get excited about it as well, that's definitely a really interesting talk to watch.
Nice. So Kevin said something that kind of made me smile a little bit. And he said that WebAssembly isn't just a thing that we run in a browser. From my perspective, and I'm not a front-end dev, right? So I've got a lot of bias here. But the WASI server-side WebAssembly stuff is probably being used much more than WebAssembly in a browser. And I don't know if that's just because I'm not in the front-end world, but I have tried to write WebAssembly to run in a browser from my website. And I just didn't think the tooling was as mature or good as what we have on server-side WebAssembly. Again, just from my perspective, I think server-side WebAssembly is moving faster and better than in-browser WebAssembly.
Yeah, I think people got to production with browser-based WebAssembly first, like Figma, for example, and Adobe and others. But I've just this is purely just observational on my part. Like there are more startups and companies that have been formed around the server side of things, whereas the web browser side of things has been more just purely community and like open source and not driven by companies and startups. So I think that could be contributing to why it seems like the WASI and server side part of it has been progressing faster, or maybe there's just more noise about it. That could be, at least from my side, that's what I've been observing.
I think it depends on the metric you're using to measure size. So, WebAssembly in the browser has probably reached more people because it's in the browser. It's probably reached more people than people don't know that they're using it. So Connor brought up Figma. There's it's making its way into all kinds of web-based applications, and it's just sort of an understood thing now. Adobe has applications on the web that use WebAssembly. So sheer number of people who have hit a web page that's using WebAssembly is probably pretty high. But to Connor's point, I think the real developer ecosystem growth right now is definitely happening on the server side.
Yeah, I'm sure there's probably a Cloudflare report, because they do these reports every year that talks about traffic and distribution and technologies being used. I'm sure WebAssembly's in there somewhere as a number, and we just have to find it. But I imagine those numbers are pretty huge. But we are approaching the end of our session, and I want to just kind of throw out and talk about Docker's recent announcement and what that means for backend developers and WebAssembly and hybrid architectures. But Docker and Containerd a couple of weeks ago announced that we can now use Containerd to distribute and pull OCI images which contain WASM binaries. These can be run side by side with containers using something like Docker Compose, and the Containerd shims even allow us to run WASI to run these workloads in Kubernetes. So we're seeing, and what I'm excited about personally, is being able to use a Docker Compose up and have like a Postgres or a Redis or whatever, my WebAssembly application running and all speaking to each other with no effort, and being able to ship that to Kubernetes. And I'm curious what your thoughts are. Do we think that hybrid architectures with containers and WebAssembly side by side is going to be the next big thing over the next 5 years, let's call it?
I don't know if it's the next big thing as much it is a necessary step in bridge building. So right now, like we said, we all pretty much agree that the ideal future is one where you just build a WebAssembly component and then you choose where to deploy it based on the features of the host runtime you're deploying it to. It's no longer a technical concern. It's more, just shopping for features. And to get there, we need to bridge between people's legacy code today and people writing greenfield WebAssembly components. And so one of those steps is to make it so that people can run certain types of WebAssembly workloads in Docker and, with run WASI and things like that. I think it's a little misleading because there's only a certain type of WebAssembly modules that you can run in these things. If you're building a WebAssembly module that uses a very specific subset of WASI, then it sort of just works. But if you need access to other types of runtime services, maybe ones that you need access to through the component model or through proprietary interfaces, you can't get those in the Docker environment. So there's still a lot of work to do, but it's a foot in the door and a step in the right direction to get adoption going. So we start out with hybrid architectures, and then eventually we move to the pure electric model, right, where now we're not tethered to any of the legacy stuff. Our greenfield stuff works just fine.
I'm going to need some more hyperbole here. You start your sentence with, yes, this is the next big thing. If you're not writing WebAssembly next to your containers, you're going to lose your job and you're not going to be a developer anymore. That's what we need to tell people, right? but that was your answer was too balanced. I'll edit it up. It's fine. Don't worry about it. Any thoughts, Kate or Connor?
I would just say, as a short answer, I do think containers and WebAssembly will live next to each other. And that will probably happen for a long, long time, if not forever. Um, because people might not want to move their legacy code to WebAssembly, and also some things are suited well for containers. Like we said, those databases that maybe your WebAssembly module still communicates with. Whether Kubernetes or Docker is the way you want to orchestrate or run WebAssembly, right now it is a great stepping stone. Like Kevin mentioned, it might not be fully featured, and maybe it will become fully featured, or maybe there will be something else that will better suit running and orchestrating WebAssembly.
Yeah, I think Docker is a very common tool for developers to have in their toolkit these days. They probably already have Docker Desktop installed. And so Docker is essentially giving the WebAssembly community a bit of a boost here, where if a developer comes across WebAssembly, they're interested in trying it out, Docker just lowered the bar in terms of complexity to get started and try it out, which is undeniably a very important thing. Whether or not the Docker Compose method of combining containers and WebAssembly will be the thing that is shipped to production environments, or whether it's even the paradigm that we use going forward, I don't know. And whether Kubernetes is involved or not, I don't know. There's obviously, you can find tons of think pieces about that around the internet, and I won't go into it. But I think Docker is just such a well understood tool for a lot of people at this point. And it's going to be, as both Kate and Kevin said, it's going to be a stepping stone. It's going to be a bridge. It's going to be a step towards getting us to that next evolution where WebAssembly is just a fact of everyday life. We'll sometimes use it, sometimes not. Maybe we won't even know. And this is a good step.
Awesome. Well, thank you all so much. It's been an honor speaking with you all. I'm now going to allow you all just to have some shameless plugs. Feel free to share links, Twitter handles, websites, anything that you want with the audience, and I'll make sure that they are all in the show notes too. So we will work in reverse. We'll go with you, Kate, first, if you want to start, and take it away.
Okay, well, I guess you can find me on Kate Goldenring at Twitter, but for anything, if you're curious about Fermyon and on how it does serverless WebAssembly, that's simply fermyon.com. And you can get started deploying serverless applications to Fermyon Cloud, and we say 66 seconds or less. So we're really about that WebAssembly, easy to get started, developer experience. And that's, we mentioned key value a lot. And in part, we just launched key value support in the cloud. So if you're excited to see what that looks like right now, you can go ahead and try that out.
Yeah, you can find me on pretty much anything at Cohix, Cohix, the Hachyderm server on Mastodon, Twitter, Blue Sky, but I haven't logged into that more than one time so far. As for Suborbital, like I said at the beginning, we help you integrate a plugin system into your SaaS application. Uses our globally distributed edge network to execute these untrusted plugins, and the developers can write plugins using a completely web browser-based code editor. No local installs needed, and you can check all of that out at suborbital.dev.
So Cosmonic is, that's my product, and we provide a managed hosting environment for WebAssembly applications. And so you can deploy components, you can deploy modules. We have key value store up and running. We have what you deploy can have public web endpoints. And so we talked earlier about the need to orchestrate applications, and you can orchestrate a distributed WebAssembly application in Cosmonic with no need for Docker. And yeah, the website is just cosmonic.com, and there's a launch button in there for our free trial.